Okay, we can start.
Good morning, respected teachers. I'm Shailendra Aote, delivering a PhD pre-submission seminar on development of an algorithm to enhance the performance of particles of implementation under the guidance of respected Dr. M.M. The things which I'll be covering are first of all basics of optimization and what particles of optimization is. Next one is literature survey. Third one, a new particle sum optimizer for large-scale optimization problems, and improved particle sum optimization based on human behavior. Chapter 5 is on particle sum optimization based on linear strategy. Next, based on task assignment, finally the conclusion and future work and references. So let's talk about what optimization is. So
Let us try to complete the presentation within 35 to 40 minutes.
Actually, based on the literatures and shortcomings in the literature, the problems are categorized as the main aim of the research work is to enhance the performance of particle sum optimization by avoiding the premature stagnation while finding the solution. Second, defining the new velocity update equation, and third, defining suitable method for parameter adjustment. And this research mainly deals with the development of an algorithm to solve large-scale dimensional problems. So the first method which we propose is a new particle sum optimizer for large-scale optimization problem. The proposed technique, like a new particle sum optimizer, is called as PSO-LSO, has effectively solved the LSO problem. This method is divided into three sections. First one, it divides the dimensional space into equal subcomponents, and more frequent random subgrouping is used, which is actually proposed in 2012, or which is actually used in CCPSO2. Second, the change in velocity update equation is proposed, which considers ghost particle in the equation. And lastly, the new method is designed, which helps the song to move away from the stagnation region. A more frequent random grouping is randomly divide the d-dimensional space into fixed subcomponent. The advantages of dividing it randomly is the probability of placing two interacting variable into equal subcomponent becomes higher, and that is given by the binomial distribution theorem. So, if we run the algorithm for 50 iterations, then 50 executions of random grouping will occur, and that time probability of placing two interacting variable into same subcomponent is 0.9948, and where x is the number of observed successes over 50 runs. It shows relatively high probability of interacting variable into same subcomponent. The second part which we have added is subtraction of the Gauss particle contribution, that means repulsive force we have subtracted. So instead of using base particle only, the contribution of Gauss particle is subtracted from the equation, and the main velocity equation is modified as, that means minus C2 rand into PWT minus XID. Here we have taken C2 as a multiplicative factor because again that C1 is talk about cognitive acceleration coefficient and C2 is social acceleration coefficient, and that Gauss particle is again the part of a social behavior, therefore C2 is considered. The next is methodology to deal with the stagnation. What we do, in each iteration we record the position of the global base particle. If stagnation occurred, we find out how many times a particle becomes global base, and this count, when we have that count, we sort the particle in descending order. So first half of the song remains same because those particles are nothing but good performer, therefore we will not change those particles, but for second half of the song we will go for updation, and those updations are, for second half of the song a new song is generated around the base particle on a circle of radius. So that radius is calculated, find the minimum distance from base particle, first to base particle, use this distance as a radius and generate the new sum around the base particle. This distance is Euclidean distance which is used to calculate the radius. Here the value of C1 C2 is used, so we have conducted the experiment to decide the value of C1 C2, and it shows that larger the value of C2 as compared to C1 shows better performance. So we have taken C2 as a decreasing from 3.6 and C1 increasing from 0.4.
What do you do with the second half of the formula? You are actually categorizing, I mean, ranking the particles according to their thickness or what?
Yeah.
Then you were, from the second half, you are selecting the two base particles.
Yeah. So that is the algorithm. Divide the sum into subsum along S dimensions. For each group, find the velocity of subsum as per the new velocity equation. Update the position for each subsum, evaluate the subsum and store the index of the base particle. So that will be used for in case of stagnation. Merge the subsum along dimension, evaluate the sum and repeat the procedure from step 1. But if the stagnation occurs, what we do, we have already stored the index of the base particle and count the number of times the particle becomes global base and sort the position as per the count. First half number of the particle remains same, but for the second half of the particle, calculate the Euclidean distance between first base two particles, re-initialize the second half of the sum with the radius calculated as that. And we have
How do you know that stagnation occurs? Each stagnation, how that condition is being changed?
We have also checked it for, that is for 10 number of iterations, 50 iterations and for 100 iterations. So when we get same kind of results for 50 iterations, then we will check it for 50 iterations, and when
for 50 iterations the base particle is not changing its position significantly,
then that condition is considered as stagnation. So the experimental result, the PSO LSO is compared with SPSO 2011 and DECCG on CEC 2008 test tube, whereas it is compared with CCPSO2 and DMS PSO on CEC 2008 test tube. The experiment is run on MATLAB 7.9 Windows i3 processor with 4GB RAM. The algorithm is evaluated for 5 lakh iteration in 25 runs. Its mean and deviation values are considered for the comparison. So the values inside the bracket is standard deviation and outside the bracket is mean value. So we have compared and we get for 35 parameters PSO LSO performs well, whereas for 5 parameter DCCG performs well.
35 functions or 35
No, parameters. Standard deviation plus mean. So there are total 20 functions. So total parameters are 40.
Okay.
So that is 35 parameter and 5 parameters. Above table shows the performance of comparison of the PSO, LSO, SPSO and DECCG algorithm on its mean and standard deviation. Sign test is used to compare the algorithm. For both the for the CEC 2010, PSO LSO performs well on 35 parameters, whereas DECCG performs well on 5 parameters. SPSO 2011 doesn't perform well on any function. It is found that PSO LSO algorithm does not perform well for last two functions because these are fully non-separable problems, and our algorithm fails to find the solution for fully non-separable problems.
Did you code for this SPSO 2011 or you obtained the code from the Maurice Clark's website?
Yeah, from the Maurice. Next is we have compared PSO LSO with CCPSO2 and DMS PSO2. DMS PSO. We have gone for a t-test and we have find the p-value for each one. Now here W is a win position, number of times it wins, L is number of times it loses, and NC is number of times it doesn't get the conclusion. So we have found, as compared to the CCPSO2, that is one of the best algorithm in cooperate for last dimension problems. So PSO LSO performs better as compared to CCPSO2 on all the functions, whereas it performs well for 4 functions with DMS PSO. Actually, first of all, I have gone for sign test here, but in FICTA I have presented the paper. You were there as a session chair. You suggested me to go for t-test. That is the optimization graph for 6 functions for CEC 2010. Sorry, CEC 2008. From the result, it is concluded that PSO LSO outperforms CCPSO2 on all the functions, whereas on 4 functions as compared to DMS PSO on its mean and standard deviation. Statistically, it performs well on all the values. First 2 functions are unimodal and remaining 4 functions are multimodal for CEC 2008. The complex problems with higher dimensions are easily solved with the algorithm. For multimodal functions, there are always the chances of stagnation which gets removed by exploring the another reason by the proposed method. Final remark for this model. Here we propose a new algorithm which forms the group along dimensions so that dimensional space is decreased, which result in finding the better value. The new velocity update equation where the repulsive force of worst particle is subtracted to improve the performance. By improving the value of C1, C2, the performance of proposed algorithm increases. The technique of moving the sum outside the local minima where the particles are reinitialized around the global base helps to move away from the stagnation. So based on this topic, paper is published in FICTA, which is held in 2014. Next is an improved particle sum optimizer based on the human behavior. So what is human behavior? When a group of people move from one position to another, then always mature people take the decision, and there are some immature people who always follow the mature one. So that phenomenon we try to map in the PSO. So nature-based particle sum optimization, that NBPSO is a technique which improves the performance of particle sum optimization by happening signature. So here it utilizes the concept of mature particle which has the decisive ability to find out the solution. So the question is how to decide the maturity in terms of simulation. What we did, we run the algorithm for 100 iterations. Initially, roughly it is triple the size of the population and evaluate the performance. Those particles which never become global based are considered as immature, and those particles become global based are the part of mature group. So what we did for the mature group, we did not have any changes, but for the immature particle we go on updating its velocity, and velocity is equals to W into velocity plus 2 into C1 G base minus velocity. Whereas value of C1 and C2 is used by having different experimentation. That formula we have used to find out the value of C1 and C2. The proposed algorithm initializes the position and velocity of the sum for first 100 iteration to compute the new function values and find the p-base. Find the new velocity and position equation as per the equation 1.3 and 1.2. Mark the particle which becomes global based. So count the number of particles which never becomes global based. Those particles are immature. Form the group of mature and immature particles. For next iterations, mature particles follow the same velocity position update equation as the general velocity update equation. But for immature one, velocity and position gets changed. And if stagnation occurs, what we do? In case of stagnation, instead of selecting global based as well as P based, what we do? We select two random particles in the search space, and we take the reference of those particles to find out the position of the position in the next iteration. So when the stagnation occurs,
that's not a convex combination. Can you go back? W star pause. What is this W? This W and C1 are same as the velocity update equation.
that W.
Same W. Here.
Yeah.
And same C1.
Same C1, and here only C1 is used.
Two random particles from the swarm you were taking, and
Yeah.
you were finding the new position.
Yeah, new position based on these two.
Why you are not taking the convex combination of these two random particles? Would have been some constant x times cos 1 plus 1 minus x times cos 2. Okay, that's fine. I mean, somehow you are initializing it. And this 1 to 100, you are using many iteration rates. I mean, you are first using 1 to 100.
Yeah,
Is it
actually it is
giving
for
the same across for all functions? Is it giving you good result?
Yeah, for maximum function it is giving good result. Because for 1 to 100 we are deciding the maturity. So for first 100 iteration we are finding the mature group and immature group, and after that we will move forward.
So did you do all experiments with keeping the same maximum number of function evaluations as given in the technical reports?
Yeah. So what we do, we have taken two types of experiments we have conducted here.
How you are deciding this total number of iterations? It should be decided by dividing the
1000 into n.
with.
Actually, it is 1000 into n. N is the number of dimensions we are using. So if we solve it for
No, that's fine. Then how you are deciding the total number of iterations? So what is your swarm size?
Swarm size is 30.
30.
Yeah.
So if your number of function evaluations is suppose 1 lakh,
Yeah.
the total number of iterations should be 1 lakh by 30. Are you using this method?
No.
I mean, each
No.
particle is evaluating the function, objective function once in
Yeah.
each iteration.
Yeah.
So if there are 30 particles, so 30 into number of iterations
Yeah.
should be equal to total number of function evaluations.
No, actually I'm not doing that. First of all, what I did, because we have compared that algorithm with AGPSO.
Yes.
They had to have a proper comparison. We had initialized, or we have run it for 5,000 iterations only, and we have compared
5,000 iterations.
But when we compare to test the scalability, we had also gone for 1,000 into n. So like 1 lakh for 1 lakh iteration, we had compared for CAC 2008.
Are you confusing between iterations and function evaluations? These two are different things.
Yeah.
So how can it be 5,000 iterations?
So
1 lakh iteration is impossible. 1 lakh can be the number of function evaluations, isn't it?
Yeah.
So my question is, if you have a swarm size n, a number of iterations suppose g, a number of function evaluations suppose f is, then n into g should be equal to f is.
Yeah.
But from that equation you can find out what is the total number of iterations that you are going to allocate.
No, actually
for this
here I
problem.
have taken the 5,000 iteration as a static one.
So for all algorithms you are running all of them for
For 5,000
iterations.
iterations.
But that may not match with the CEC technical reports. They are prescriptions. Anyway, go on. But
When stagnation occurs, it is necessary to move the particle in some other region. As a personal waste and global waste are responsible for stagnation, it is better to avoid the use of these components. Consider two random particles around the current particle. Resultant of these two particles maintain the magnitude, but the direction of base particle is changed. This helps the particle to move away from the stagnation region. So, consider the swarm size is 30, then the probability of selecting two random particles is PR equals to 1. But selecting the P-based and G-based is equals to P of G, that is 0.0023. And when we run the algorithm for 50 iterations, then that probability becomes 1.088, which is, so P of R is greater than P of G. So selection of random particle gives better result as compared to selection of P-based and G-based. So that is the like when that is a base particle we have. That is particle 1, particle 2, these two particles, and resultant of these two particles is A. But when we follow that A, we are not getting the better result. What we are doing, we are changing the direction of particle 2, and we are finding the resultant, and that resultant is the new position. The new position of particle is a resultant of particle 1 and opposite of particle 2. So that time the A changes by angle theta, and we get the new position as a P. 13 functions from the test tube provided in AGPSO are used for performance evaluation of the proposed algorithm. The algorithm is evaluated up to 300 dimensions per 5,000 series.
full form of AGPSO.
Autonomous group particle sum optimization.
Where was this paper published?
It is available in Journal of Science and Engineering, Spring publication.
And why you are using this AGPSO for you as your benchmark algorithm for comparison? Why not you are using some other, I mean, CLPSO, which is the most prominent PSO very much?
So actually for higher dimensional we have compared it with
Have you compared it with CLPSO?
CCPSO for higher dimensional.
That's for higher dimension.
Yeah.
For dimension, why you are comparing with AGPSO?
Because we have got the code of AGPSO.
CLPSO code is also public. You can consider comparing with that. That was published in IEEE Translations on Infocomm, and it has highest number of citations in all
CLPSO.
Comprehensive learning case. Anyway, you go. This journal where this AGPSO is published is not that well known.
The side test is used to compare the performance of NBPSO with the other algorithm where significance level is taken as 0.05. And so those are the results of AGPSO, that means NBPSO is compared with AGPSO 1, 2, 3, IPSO, TACPSO and MPSO, and we found so the proposed algorithm is superior as compared to the other algorithm on mean, median and the base values. The performance is better because of the randomness in selected points around the base particle in case of stagnation. It is seen that when particles when the global optimum falls into local optimum, proposed method moves the swarm into another region. This increases the chances of exploring another region, which in turn gives better fitness value. The natural selection strategy of deciding maturity, which initially finds low performing particles and avoidance of those particles in decision making leads to a better solution. So for finding the convergence speed, we find out how many iterations it takes to reach that particular threshold, and the experimentation is also performed to find the number of iterations required to reach the predefined threshold.
This should be changed to the number of FEs required to reach the predefined threshold.
This is used to test the convergence speed of the algorithm. Result in the table shows that proposed algorithm has greater convergence speed as compared to other algorithms. 10 runs are performed to reach the threshold and the number of iterations required to reach the thresholds are noted down. Table shows the mean number of iterations required to reach the threshold. The rank method is used to test the performance, and our algorithm achieves first rank on 11 functions out of 30. So those are the convergence graph of on 30 functions where our algorithm has the best performance.
Is the y-axis logarithmic scale or not? Logarithmic scale.
So to support the claim and the study of the scalability of the proposed method, the algorithm is evaluated for on 7 functions CEC 2008 test. Its mean performance is compared with state-of-the-art algorithm like CCPSO2 for 500 and 1000 dimensions. So results for CCPSO2 are taken from the paper. Unpaired t-test was conducted with null hypothesis stating that there is no difference between the two algorithm comparison, and the null hypothesis was rejected when the p-value was smaller than the significance level alpha equals to 0.05. The NBPSO performs extremely well as compared to CCPSO2 on 4 functions for 500 and 1000 dimensions, whereas no conclusion is made for that is not showing properly. So no conclusion is made for results of 2 functions for 500 dimensions as well as 1 function for 1000 dimensions. Both CCPSO2 easily handle the last key optimization problem. The proposed algorithm of avoiding local optimum gives better result. So the p-value we have taken. So for these we have not compared because it is not matching for the p-values. For 4 functions and for all the 4 functions it is giving better results. Final remark: a new modification in existing PSO is proposed based on the observation in nature. The concept of
compared with CC10 on this.
Actually, the results for CCPSO2 are present for 2008 only. This is for 500 and 1000 dimensions. So to test it, it is better to conduct it on CC2008.
You didn't test NBPSO on any of these CC10 functions?
No. NBPSO is for the test suite which is provided in AGPSO and the CC2008. A new modification in existing PSO is proposed based on the observations in nature. The concept of forming groups based on maturity of particles and technique to deal with the stagnation gives better results on multimodal functions. Avoidance of taking reference of global-based particle because of which stagnation occurs and considering the direction of a randomly selected 2 particles gives better acceleration to move away from the stagnation. The proposed method NBPSO is executed on test provided in AGPSO and it is found comparatively well as compared to other algorithms. The proposed method also compared the state-of-the-art algorithm on CEC 2010 test to study the scalability of the algorithm. So based on this, paper is published in the same journal, that is SCI journal actually, Arabian Journal of Science and Engineering. So that recently it is published on 7th December.
Consider publishing in some core journal which relates to at least
actually, same time I have submitted it.
Why you submitted to Arabian Journal of Science and Engineering?
Actually, same time I have submitted it to Biosystem, elsewhere journey. So when I got the acceptance of when I got the final acceptance, some modifications they asked, but because I wanted to publish that paper, therefore I rejected to send the modifications in those Biosystems elsewhere journey.
Always try to publish in core journals which are a little bit narrowly focused. Science and engineering, journal of science and engineering makes no sense. Nowadays the umbrella of science and engineering are so large, pretty well know that. But this work can have some more things inside it. I mean, you can, before submission of your thesis, you can try to, I mean, NBPSO you are comparing with AGPSO. AGPSO is published in this journal. And this journal is not well known to any people in evolutionary or material or researchers. So So I would suggest that you compare your algorithms. Your algorithmic part is okay. I mean that development is fine. I have no objection, no big objection about it. But the testing procedure should be improved. What you can do is you can compare it against at least 1 to leading algorithms from IEEE transactions. Like CCPSO2 is fine. It's from IEEE transactions. Similarly, CMPSO you can compare, and also this MBPSO you can test it separately on the CC 2010 benchmarks. Because it should not be like that you are proposing 2 algorithms and testing them. 2 algorithms are for similar tasks, but you are testing them on two different benchmarks. Why it should be so? Obviously, the reviewers of the thesis will ask this question. So you should try to insert a few more pages and make the benchmarks uniform. This is one thing. Another thing is, I was also looking at this thesis. You are using equations by using MS Word only. Why you are not using a equation editor? The equations in slide also are very badly written. तो होता है ना इक्वेशन एडिटर होता है माइक्रोसॉफ्ट इक्वेशन एडिटर में ऐसा कोई सॉफ्टवेयर यूज करते हो वर्ड में ही मिलता है
हाँ सर इसकी तरह हुआ है
no you are giving this star is not a it should be dot and all the math fonts should be there. Try to reduce math fonts. Try to see how the people are writing equations for PSO papers in IEEE transactions. Say actually students should be encouraged for using Latin for writing this kind of mathematical optimization based thesis. Experimental rock ठीक है वो वर्ड में हो जाता है लेकिन यूज करना चाहिए. However, another thing is if this range is final, then it is also you are getting development of an algorithm to enhance, but it is actually 2 different philosophy. I mean, in your thesis you are using 2 different philosophies for enhancing PSO. So why an algorithm?
Yeah, we said that.
Development of
That is suggested.
to enhance performance actually is saying 2 different things. Okay, anyway, that's fine. Thank you for the presentation. Oh, and one more is
for Simco, जो Simco में हो रहा है topic.
अच्छा हाँ.
So the particles of optimization is based on business strategy.
ये n को change करना.
Particles of optimization based on business strategy. We have taken the comparison benchmark algorithm is competitive sum optimizer, which is recently proposed in IEEE transaction 2015. So what CSO says, when we have a sum size n randomly divided into m by 2, where each group contains 2 particles. Have a competition between them, the loser particle will go in updating its velocity and position, whereas winner will go in next iteration as it is. So with that, CSO performs well on higher dimensional problem, but the problem is some kind of randomness are involved in new generation as well. But actually, when 2 particles are selected, then the loser particle is updated and winner particle is transferred to a new generation. But the problem is, when competition will perform between 2 particles, loser may be the winner for another competition. Therefore, to remove that drawback, we have designed particles of optimization based on winner strategy. Instead of considering P-best and G-best, we consider an immediate winner particle for each. So in each iteration, it first evaluate the sum to calculate the fitness, sort the sum in increasing order of the fitness. The base particle follows the general velocity and position of the equation, where the third part of the velocity equation is absent because the base particle itself is a G-base. Other particles consider their immediate winner particle for position update. Immediate winner particle is termed as, if I is the current position, then I minus 1 is considered as winner position. Then there is a need to change the position of I particle. This strategy is more promising as no randomness is involved to define a winner. So that will not be an exact competition, but it will be a competition sort of things where 1 and 2, because always 1 will be the winner, so 1 will be transferred as it is, whereas 2 will updates the position, updates its velocity by using that formula.
Are you time minus 1? These are the indices of the particles in an array. They may not be geographically close to each other.
No. Based on the fitnesses that we have.
Are you considering topological neighborhoods here?
No.
Why you are considering I minus 1 as the
Because if we want to make in CSO, what they did, they have randomly selected two particles and they randomly had the competition between them. But what is the problem? If that is a loser, but that loser may be the winner for another group. Therefore, that is the loophole which we found in that CSO.
So also you are doing the same thing. I and I minus 1, these two particles are like two randomly selected particles.
No, actually, when we sort the sum, then we get the highest fitness sum at position 1,
Okay,
then second.
So I and I minus 1 are the
Yeah.
indices in the sorted.
Phi is used to control the distance of the previous and current velocities, and to decide the value of phi, we use d, mean distance between velocity of current particle to all the other particle, and d dash is the distance of I and I minus 1 particle. So if d dash is less than d, random value of phi is present in between 1 and 2. If d dash is greater than d, it is present in between 0 and 1. The proposed algorithm, sum size, number of dimensions, initialize the position and velocity of the sum. While combination criteria is not satisfied, sort the sum. The base particles follow the same velocity and position of the equation. For j equals to 2 to size of the sum, the velocity is given as. Evaluate the sum. If the fitness is less than the previous fitness, then its previous position will be given as the current position. Experimental result, we had again conducted it for 1000 dimensions. So to decide the value of sum size, we have conducted the experiment, and 100, 300 and 500 sum size we have taken for 100, 500 and 1000 dimensions respectively. 50 independent run we have, and the maximum number of functions evaluation here we have taken as a 1000 into n. To compare the different statistical results under the test, and it is compared with CSO and CCPSO. So for 100 dimension, again the same, that is the p value we get, that is the standard deviation, that is the mean value, PSO, WS, CSO and CCPSO. So it is winner for 6 as compared to CSO for mean, and for standard deviation it is winner for 5. As compared to CCPSO, it is winner for 3, whereas no conclusion can be made for 4 because we are not getting static. That means these two means are statistically different. So for 3,
No conclusions can be made means they are statistically equivalent.
yeah,
You better say they are equal.
yeah.
It is good, actually it's not worth in any case.
So that is for 500 dimensions. Again, it is 6 and 5, but it is 4 and 4 here. For 1000 dimensions, it is 6 and 5 and 4 and 4. So that is the mean convergence graph for all these 6 functions. Conclusion: a new strategy based on a winner particle is proposed. This winner particle is uniquely winner of any particle. After sorting the fitness of a particle, each particle updates its position based on the better particle. If the new position is better as compared to previous position, then it is accepted. Otherwise, its position is replaced with the winner particle position. To have a better exploration, dimension dependent sum size is used. This sum size is decided by conducting the different experiments. The proposed algorithm is compared with 2 state-of-the-art algorithms for large-scale optimization of 100 dimensions known as CSO and CCPSO2. Statistical results show that proposed method performs extremely well for most of the functions. Based on that, the particle sum optimization based on winner strategy, this is accepted in Synco and it is registered. The presentation will be on 19. The last strategy is particle sum optimization based on task assignment. There the inspiration is again from PSOWS and CSO. What we do in PSOWS, we sort the sum and only we consider every particle is a loser, every particle is a winner except the first one. So instead of doing that, what we do, we form the group of completely winner and completely loser particle, and the third group consists of winner as well as loser particle. So for the first group, the velocity update equation we have taken. So here the third part is absent. That means social part is absent because the third part will be absent. As a winner particle is G-base particle, and difference between G-base and winner particle will be 0. For the second group, its cognitive part is absent because if it is a loser, then why it will consider its personal best. And for the third group, it will add, that means instead of having a global best, what we do, we find the mean of, that means the difference in this model is that instead of GPS position, it uses mean of all the particles in the third row. So that is the algorithm based on the scenario. Here, to decide the value of WC1 and C2, the relation we have taken WC1 plus C2 is equals to 4, and for group 1, C1 is equals to that, C2 is equals to 4 minus W, and for G3, C1 is equals to random in between 0.5 to 1.5, and based on that, value is defined. Where W is ranging from 0.9 to 0.4, and therefore initially C1 plus C2 is equals to 3.6, and it will decreases as the number of functions evaluation increases. Experimental result, the sum size is same as the previously used. 15 independent runs are taken for each function and its mean and standard deviations are noted for comparison. Maximum number of functions evaluation are 1000 into n, where n is a search dimension for the test function. And again it is compared with PSO-TA is compared with PSO-WS as well as with the CSO as well as CCPSO2. But for the 100 dimensions it performs well, but for 500 as well as for 1000 dimensions it doesn't perform well. So from the table it is found that PSO-TA does not perform well on higher dimensional problem. For 500 and 1000 dimensions it could not win the game, but for 100 dimensions it is winner for 6 functions on win, whereas for 4 functions on the standard deviation. To better understand the performance of PSO-TA for smaller dimensions, it is evaluated for 30 and 50 dimensions, and the sum size is taken as 30. And for 30 and 50 dimensions, the performance of PSO-TA is better as compared to PSO-WS, which is proposed by us. So remark, a new strategy of forming the group of winner, user, and both winners and users is proposed here. Different velocity update equation applied to each group. This strategy is an inspiration from PSO-WS and CSO. This is not good for higher dimensional problem, but for smaller dimension problem it performs well. So it's all about how the thesis is summarized. Chapter 1 is talking about single objective optimization problem and particles of optimization. Chapter 2 deals with the literature survey. Chapter 3 deals with the PSO-LSO algorithm. Whereas chapter 4 proposes, chapter 4 is about human spatial behavior based on the concept of maturity and immaturity. Next is on PSO-WS, where chapter 6 ends with PSO based on the task assignment. Those are the advantages of PSO. The conclusion, the large-scale optimization problem are solved by using proposed technique. These techniques involve the development of new PSO to solve multi-dimensional problem. Writing the velocity update equation with involvement of repulsive factor and technique to deal with the stagnation gives better result as compared to SPSO11, DCCG, DMS PSO and CCPSO2. Improved particles of optimization algorithm is also proposed, which follows the human social behavior. The drawback of CSO is removed in PSO-WS by proposing the proper computation strategy and new velocity update equation for user particle. Finally, the PSO-TA is proposed by taking inspiration from CSO and PSO-WS. Here, the results are not good for higher dimensional problems, but the results are favorable for small dimensional problems. That is a future scope where PSO-TA can be improved for solving larger scale dimensional problem, as well as all the proposed algorithm can be solved for real life problems. Those are the publications, 4 international journals and conference.
Where from you are getting that, what is the reference for that equation, W plus C1 plus C2 equal to 4?
Actually it is proposed in...
that reference should be mentioned, it's coming from some mathematical analysis.
Actually it is from, I am not remembering actually, but it is from CSO.
It's from CSO?
Yeah.
CSO was published in which transaction?
Identical transaction. February 2015.
What is the name of the transaction?
Man and cybernetics. It may be present in the literature or
you could have some real life problems by for solution with this one of these algorithms.
Identical transaction of cybernetics.
You have tested mostly on benchmark problems. Fine, try to make the benchmark testing uniform, try to write the pieces in better text processors using the process of equation. I think